Hello Varun, good evening. Hello, good evening. Are you there? Put on the headphone, man. Where is the headphone? What happened, Varun? Have you forgotten to put the headphone? Shall we start the class? Yeah. I've been waiting for 2 minutes. Huh? Yeah. Right. The last class, we have learnt about the resistivity, isn't it? Specific resistance or resistivity of different materials. On what factors do the specific resistance or resistivity depend on, isn't it? Now we would have seen the tabular column. Of course, it is not for examination, it's only for reference. To understand, the various ranges of the resistivity of different metals, alloys, insulators, it is given. It's only for reference. You need not memorize it, of course. Right? Now, in continuation with that, today we'll see some of the important numerical problems followed by some important questions. Okay? Now, the first question, whatever questions we are going to see, numerical problems we are going to see today, it is mostly based on Ohm's law. Right? It's only the relationship between potential difference, current and resistance. In that way, it will be very easy for you to understand. Okay? Have you got stuck anywhere? Yes? Is there any problem with the internet connectivity? Right? Shall we continue? Yeah, what happened? Okay, you got stuck somewhere, is it? Okay. Right. So as I said, the numerical problem which we are going to learn today is based on Ohm's law. Okay? Yeah. Okay. So it's all based on Ohm's law, which is the relationship between potential difference, current and resistance. Okay. Now let us take the first problem. It's one of the simplest problems which we can see. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms? Right? What is the question? We have to find out the current. So I'll just solve that. You can also note down. If you got a notebook, you can just note down whatever the problems we solve. Please note down. It will be easy for you to refer in the future. Okay? Right. Now let us take what is the data given. So what is the data given here? voltage is given, that is potential difference. So we have to take it as potential difference. Potential difference is indicated by letter V, which is given as 220 volts, isn't it? So write it as 220 volts. And then if the resistance of the bulb filament is given, that is the resistance is given. So take this as resistance. So resistance is indicated by letter R. So it is 1200 ohms. Okay. Now what is this question they are asking? How much current? So we know that solution. So we have to write according to Ohm's law. According to Ohm's law. What that Ohm's law says, V is equal to IR or I is equal to V by R. So what we are asked to find out? Only current. So we have to write I is equal to V by R, which is from this expression we can say V is, how much is that? 220 by R is 1200. Now can you tell me how much is that? What is the value of this? Can you tell me, find out quickly? How will you find out this fraction? It's only by, hello? Just look at that, okay? See, how will you calculate? See, you have to cancel 0 first. Yeah. Now we have to cancel, use 2 as the common factor. So here it will become 11, here it will become 60. Isn't it? Right? So how will you divide this? 0 point. Yes? Yeah, tell me. Point. How will you divide? Do you know that? 11 divided by 60. So you have to put 0, add 1 0. So one time you can say it is 60. What is remaining? 50. Isn't it? Right? Okay. Again you can add 0. 8 times you can say 480. So it will go on like this. So we can find out only the first 2 digits. So the unit of current, you know, it is ampere. So I is equal to 0.18 ampere. Right? So this is how we have to find out the answer. Are you able to hear me? Varun? Hello? Hello? Varun, are you there? Hello? Are you there? Yeah, there is some problem with the connectivity. Yeah. Okay. Just note down that. As I said, it is according to Ohm's law. Yeah. According to Ohm's law, I is equal to V by R. So, as we can see that, how we are calculating, we can cancel the 0. It is 11 by 60. Since this numerator is greater than the denominator, we are adding 0 and put point here. So that we can say that one time it is 60, remaining 50, add 0, so that 480, it will keep on going like this. So since the digits are given here, it is, we are finding out current, it is feeble current. So we can take only first 2 digits, that is enough. 0.18 amps. That is the answer for this question. Okay, have you noted down this? Of course, some problems are given in the textbook, but you have to note down so that you know how to work it out properly. Okay, so that will be easy for you to refer in the future. Because in the textbook, some steps may be skipped. So at the time of examination, it will be easy for you to refer. Okay, let us go to the next problem. Next one. How much current will an electric heater draw from 220 volt source if the resistance of the bulb heater coil is 100 ohms? Right? How much? What is the question? Second question. In the same question, how much current will an electric heater coil draw from a 220 volt source? The resistance of the heater coil. Okay, if the resistance of the, this is not the bulb, yeah, resistance of the heater coil is 100. So what is the data given here? Take that. First data. Source of potential difference. What is the source of voltage? It is potential difference. Write it as potential difference. V is equal to 220 volts. Right? And the resistance of the coil. Resistance is indicated by letter R, and the resistance of the coil is 100 ohms. Right? Same question, similar question only. Only thing is that using this formula, we are going to take V by R. So, what is the question? How much current? So, current I is equal to. So, V by R. That is equal to, V is 220 here. Resistance is 100. So, it is, cancel 0, it is 2.2 ampere. So, this is the current which is drawn by the electric heater. Okay? Right, when the question is asked like this, you need not simply leave as it is, I is equal to 2.2 amps. You can just complete it by saying, by completing the question like this. In this place of how much, you can write it as 2.2 ampere. So 2.2 ampere current will be drawn by the heater coil. Okay, 2.2 ampere current will be drawn by the heater coil. Like this, you can complete the sentence. Okay, right? Have you noted down? These are, of course, very simple problems, right? So if you practice very well when you go to 11th standard or 12th standard, it will be very easy for you to follow it up, because more complicated questions will be there in the future. Right. The next question is, right, the potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 amps from a source. Right? Here there are two parts in the question. Right? We have to just understand what is the final question. You see, what current will the heater draw if the potential difference is increased to 120 volt. Actually, this is not required. If it is given here, we can say in these 3 variables, if any 2 are known only, we can find out the third one. But in the last line, what current will the heater draw? They are asking current. The potential difference is given. Only one data is given, but we need one more variable. To find out that variable only, the first 2 lines are given. Okay, that way we have to understand. Now let us take the first two lines. From the first two lines, what can you infer from this? They are asking current, potential difference is given. Potential difference is given, current is asked. What is required actually? Resistance is required. So, to find out the resistance, we have to use the first line. Okay? So, take the data first. The potential difference is given. What is that? Potential difference, right there. V is equal to 60 volts. Right? And the current is given. What is the current? Current is 4 amps. Right? From this, we can find out the resistance of the heater coil. Okay? So, resistance of the heater. How much is that? It is R is equal to V by I. So, you can say R is equal to V by I. So, V is here 60 and I is 4. So, 15 ohms. So, resistance of the heater is 15 ohms. Now, we will go to the second part of this. Now, we have got two data, that is two variables are given. Potential difference is given, resistance is given. So, using these two data, we can find out what current will the heater draw. So, current drawn by the heater I is equal to V by R. So, V is given. Since it is 120 volts, so 120 by, already we have got the resistance as 15. So, write this as 15. So, 8 amperes. So, the current drawn by the heater is 8 ampere. So, this is how we will have to calculate the current. Okay. So, we have to complete the sentence. What is that? What current will the heater draw? So, the heater draws a current of 8 ampere. We will have to just write a sentence, add the sentence. Okay. Is that clear? Yeah? Shall we go to the next one? Shall we go to the next one? Yeah. Okay. We'll go. We'll take the next one. Now here, this question is about resistivity. Okay. We know resistivity of a material using this formula. We have to recollect that resistance is given by directly proportional to the length of the conductor, inversely proportional to this area of cross section. By this way, you can find out rho is equal to RA by L. Using that formula, you are going to apply here and get the answer. So, what is given here? Resistance of a material of wire of length is given 1 meter and resistance is given 26 ohms. The diameter is given. Here, to find out the area, we need, when you are taking a wire, it is in the form of a cylinder. Okay. So, to find out the cross sectional area, it is like a circle. So, you know the formula to find out the area of a circle. Can you tell me what is it? Area of a circle. Yes? Exactly. So, using that area is nothing but pi r square. So, we have to substitute that. Now, take the data. The length of the wire is given. The rest of the metal wire. Length of the wire. Take this as length of the wire. Yeah. So, length of the wire L is equal to 1 meter. Usually, sometimes they may give this in terms of centimeters. Right? In case if they have given us 96 centimeters. So what will you do? Because you know that resistivity unit is ohm meter. Okay, so when you are giving the answer as ohm meter, whatever the data we have taken here should be in terms of meter. Suppose if it is 96 centimeters, what will you do? Yeah, it is 0.96 meter. We have to divide by 100 or into 10 power minus 2 meter. Right? That way we have to convert it. Suppose if it is 96 centimeters, you will have to take it as 96 into 10 power minus 2 meter. You have to take it as meter, in terms of meter only. Then only you will get the correct answer. Okay, here it is given as meter. Direct, straight away we can take this. So length of this is given as 1 meter and the resistance is given. So resistance of the wire. So resistance of the wire, which is taken as capital R. It is given as say 26 ohms. Okay. Now we are asked to find diameter is given. So diameter of the coil. So you have to take it as D. It is 0.3 millimeter. Or otherwise, since when you are finding out this area, we need that is diameter. Radius of the coil. So you can take this as 0.3 by 2 millimeter. Right? When it is given as millimeter, so in what way we have to convert it into meter? So as I said already, everything should be in terms of meter. So how will you convert millimeter into meter? Yeah, it is. Otherwise, we can say it is 0.3 by 2 into 10 power minus 3 meter. Usually, when you are dealing with physics, we have to write it as scientific notation. We call it as scientific notation. Since instead of saying by 1000, I say it is 10 power minus 3. Okay, that is the actual method of indicating the radius of the coil. Okay. So diameter of coil is given as 0.3. So I will convert this into radius of the coil. Okay. So radius of the coil is divided by 2. Now using these three data, because to find out specific resistance, we need three data only, R, A and L. All the three are there because in A, pi r square, pi is a constant, R is only required, R we have got. So by using this we can substitute it. Now the specific resistance or resistivity of the metal. Resistivity of the, usually when you are writing this resistivity, you should not write it as resistivity of the metal, you have to write it as resistivity of the material of the wire. Resistivity of the material of the wire or resistivity of the given metal. Rho is equal to RA by L. So substitute the value. R is nothing but, here it is 26 into area of cross section, that is pi r square. Pi into R is given, how much is that? 0.3 by 2 into 10 power minus 3 whole square, whole divided by 1. Okay. Right. So now calculate it. How will you calculate? Come on. Have you noted down? I'll just solve it from here. Okay. Right. Now here. So 26 into 3.14 into, you can write this as 0.3 by 2 means 1 point. Can you tell me how much is that? 0.3 by 2 means 0.15. Okay. Right? Into 10 power minus 6. You can multiply this. 0.3 into 2. And this is also square. Okay. I can write this as it is like this, or I can write it as 10 power minus 3 into, one more time you can write 0.15 into 10 power minus 3. Okay, whole divided by 1. So I am not taking that 1. We can leave it as it is. Now multiply this now. 26 into 3.14 into, how much is that? 0. How much is that? 0.15 into 0.15. 0.15 into 0.15. 0.0 into 10 power minus 6. Come on. Find out the answer for this. How will you multiply? Yeah. 0.0225. Now multiply this. Multiply and find out the answer. Do you know how to use the log book? Do you know how to use the log book? Yeah. So if you can use the log book, you can just take the logarithm of all the three and add it and take anti-log. Okay? You don't know. They won't give. Otherwise, you have to go on multiplying only using the ordinary multiplication. Okay? So the answer is, it is 1.84 into 10 power minus 6 ohm meter. Okay? Simply by just multiply using ordinary multiplication, you can do that. Okay? It is 1.84 into 10 power minus 6. Now the next tail is there. Predict the material of the wire. So using this value, we can just compare the tabular column given there in the textbook. Which metal has got this value of 1.84? 1.84. It is nothing but manganese. Okay? The given metal is manganese. Predict the material of the wire, right? So you can see by using the value, we can say that the given metal is manganese. Okay? So that is what we have to add one more answer for this one. Okay? Right. Now, when you are free, you have to just go and multiply and find out the correct answer. Because in the examination, there is a chance to make mistake. So, practice it properly, so that you will not make any mistake. You will get the correct answer as 1.84. Okay? So, we will go to the next question now. The next question is, a wire of given material having a length L and area of cross section A has a resistance of 4 ohms. Now what would be the resistance of another wire of the same material having length L by 2, half of that, and area of cross section twice that area? So we are given 2 wires, right? By comparing these 2 wires, we are going to find out the resistance of the second material. Okay, second material of the wire. Okay, so it's very simple. See, what is the data given here? Take the data. Only the resistance, the length is given, resistance is given, cross sectional area given. So for the, or we can say for the first wire, okay, length is L, area of cross section is A, and resistance is equal to, how much is that? 4 ohms. Right. Now, since we are going to find out the resistance of another wire also, we will take this resistance as R1. Okay, because the length is L only, cross section is A, but only the value is differing in terms of multiples. So we will take L and A, only the resistance we will take it as R1. And similarly for the second wire, okay, length is L by 2 and area of cross section is twice that, twice the area of cross section. Now they are asking what is the resistance. R2 is what? This is the given data. Okay, are you able to see these letters? Is it legible? Yeah. Now, using this, now we are going to find out by comparing the resistance of both the materials. Since the material is same, the specific resistance will not vary. Okay, if only the materials are different, rho will change. Since material is same, rho will remain same, right? So by using this formula, we'll take what is that? R is equal to rho L by A. R is equal to rho L by A. Using this formula, we are going to substitute. Now take the first point of this question. Right? For the first wire, R1 is equal to rho L by A. Take this as 1. Equation 1. Say for example, equation 1. So since the value is given, resistance is given, we can say rho L by A is equal to 4 ohms. Okay, you can take this as equation 1, need not be, because we need the values only. Now similarly, for the second wire, so what do we say? Here for the second wire, R2 is equal to rho L by A, but here in place of L, it has got half of L. So I'll write it as L by 2, and in place of A, we have got 2A. Okay, right? So this is what we say R2. Now we can simply rearrange it. Okay, how will you rearrange it? See that? Rho into L by, this 2 will come here, already 2 is there, 2 into A. That is rho L by 4A, or I can write it as, see, we have to compare these two equations. Here also rho L by A, here also rho L by A, only the 4 is the difference. So I will write separately 1 by 4 and write it as rho L by A. Right. So in place of rho L by A, what is the value actually we have got here? 4. So I can substitute in place of rho L by A from this equation, so that this equation will become R2 is equal to, so we can say from 1, equation 1, okay, write it as from equation 1, R2 is equal to 1 by 4 into 4, that is equal to 1 ohm. Okay, so the resistance of the second wire or a new wire, whatever you say, so another wire we can say is nothing but 1 ohm. Is that clear? Have you understood? Now let us see some of the questions, important questions. First question is, what does an electric circuit mean? What does an electric circuit mean? So electric circuit means a continuous and a closed path of an electric current. The electric current has to flow through the circuit, and if you are supplying it with a battery, you have to start from there and close it. Then only you can say it is an electric circuit. So a continuous and closed path of an electric current is called an electric circuit. This is one of the easy questions. And then the next question, important question is, define the unit of current. As we have already discussed, you know that instead of asking the definition for ampere, they are indirectly asking the unit of, define the unit of current. So first you have to mention the unit of current is ampere. Then we have to say what is ampere, 1 ampere. 1 ampere is constituted, 1 ampere current we say 1 ampere current or 1 ampere is constituted by a flow of 1 coulomb of charge per second. 1 coulomb of charge per second through the given cross sectional area of the conductor. You know that, remember that I is equal to Q by A. In that, if Q is 1 coulomb, A is 1 area, that is Q by T, T is 1 second, then we say that I is 1 ampere, isn't it? So, 1 ampere is constituted by a flow of 1 coulomb of charge per second through the given cross-sectional area of a conductor. Are you able to hear? Have you got stuck? Yeah? Yeah. Oh, this is the definition of unit of current. Next, this is also one of the important 3-mark question. Yeah, calculate the number of electrons constituting 1 coulomb of charge. That means how many electrons are there in 1 coulomb of charge. This is instead of asking, they are asking in the indirect way. Calculate the number of electrons constituting 1 coulomb of charge. Okay, for which in the beginning of this lesson I said that E, the electrons, the charge carried by 1 electron, we have to remember, recollect that point. The charge carried by 1 electron is 1.6 into 10 power minus 19 coulomb. This has to be registered in your mind forever. Okay, the charge of an electron. Right, what is the question actually? 1 coulomb of charge, in 1 coulomb of charge, how many electrons are there? Now we can say, if 1.6 in 10 power minus 19 coulomb of charge is there, then it has got only 1 electron. Right, for this coulomb of charge, we say that it is 1 electron. Right, and similarly, if it is 1 coulomb, then how many electrons are there? See, this is the point you have to remember. Charge of an electron is 1 coulomb, that is 1.6 in power minus 19. So, if charge is 1.6 in 10 power minus 19 coulomb, the number of electrons is 1. Then what is the question? If charge is 1 coulomb, then if charge is 1 coulomb, then how many electrons? Instead of these many coulombs, we are taking 1 coulomb. So this has to go to the other side. So that means 1 divided by this one. So 1 divided by 1.6 10 power minus 19 coulomb. 10 power minus 19 coulomb. Okay. So this 10 power minus 9, if you take the numerator, it will become 10 power 1 into 10 power 19. 1 into 10 power 19. Okay, divided by this 1.6. Okay, so this can be simplified by like this easily. So instead of 1 into 10 power 19, I can write this as 10 into 10 power 18. So I can take 1 0 from this so that I can easily divide that. Okay, or you can take one more 0 also easy. Right, anyway you can divide like this. So since it is 10 by 1.6, you can calculate as 6.25. Okay, so this is how we can simplify it. Yeah, or even you can write like this, 100 divided by 16. Okay, taking 2 zeros so that this will become 16. Right, by multiplying 10 by 10. Anyway we can calculate, but the only thing is so that it will make it easier for you to calculate. So the number of electrons is 6.25 into 10 power 18. So in 1 coulomb of charge, see that you can see that how many electrons, 6.25, 10 followed by 18 zeros. These many electrons are there in 1 coulomb of charge. Right. This is how we have to calculate. This is one of the most frequently asked question. Not only for 10th standard, even in 12th standard also they ask this question. How many electrons are there in 1 coulomb of charge? Even in competitive exams also they will ask this. Okay, so remember that. By memorize also you can do that, because instead of calculate, of course you know the value of calculating the value, but just you can memorize it. In 1 coulomb it is 6.25 10 power 18. Multiple choice they may ask 6.25 into 10 power 18. Okay, so this is the number of electrons in 1 coulomb of charge. The next one is, how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts. There is a problem with your internet. Very often it is getting disturbed. Okay, so how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volts? Okay, so it's very simple that we know when you are defining the potential difference, right? We have got the definition of potential difference. Work done in moving a charge from one point to another in an electric field. Like that we have defined, isn't it? Yeah, V is equal to W by Q. Using that only we are going to calculate W is equal to V into Q. Here though we say the question is how much work we have to say, isn't it? So W is equal to V into Q. The two data given, Q is 2 coulomb and potential difference is 12. Simply we have to substitute and multiply. So 24 joules, right? We know that already I have said that this work done is nothing but the energy, we can say energy or work done, both are same. Okay, this energy in terms, sometimes they may ask how much energy is required to move this charge from one point to another. Both the way you can write, the unit is joules only. And remember that whenever you are answering any numerical problems, the final answer should carry definitely the unit. If you by chance if you forget this unit, they will reduce the mark. Okay, they will reduce the mark so that it's a trouble for you. So never forget to mention the unit for any numerical problem. Right, the next question, see. This is already we have seen. Hope that you remember that. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So what is given here? Data, current is given and time is given. Right? I is given, T is given. So I is 0.5 and T is 10 minutes. So in terms of minutes it is given, you have to complete it as in terms of seconds, convert it. 10 into 60, 600 seconds. Okay, so because I is equal Q by T, in that Q is in terms of coulomb and T is in terms of seconds. That's why we have to convert it. So from that we can say Q is equal to I into T, which is simply the multiplication, 0.5 into 600, which gives you 300 coulombs. This is the very basic numerical problems. I hope you remember that. The next one is simple one mark question. Name a device that helps to maintain a potential difference across a conductor. So if you want to maintain the potential difference across any conductor, what we require after all? A cell or a battery, which provides a EMF, so that it will maintain the potential difference across the ends of the conductor. So very simple question, remember that. Next one is, what is meant by saying that the potential difference between 2 points is 1 volt? Is a potential difference, voltage is 1 volt. What do you mean by that? Right? What is meant by that? It is nothing but the potential difference between 2 points means there are 2 different points from which we require some amount of work to do so that a charge can travel from one point to the other point. That is what it means. So the potential difference between 2 points is said to be 1 volt. What is the question? The same thing. If 1 joule of work is done in moving 1 coulomb of electric charge from one point to the other point. Actually, can you understand what should be the question? Can you put it in a nutshell instead of 2 lines? Can you put that question as only one simple line? Yeah? That's all. Very good. Excellent. Define the unit of potential difference or define potential difference. Define the unit of, it is not define the unit of potential difference. Define 1 volt. That should be like this. Okay. Define 1 volt. Unit of potential difference. Of course, that is also same. 1 volt means unit of potential difference. That's good. Both are same only. Define volt, define 1 volt, or define the unit of potential difference. In all the 3 ways it can be asked, Or the fourth one is what is meant by saying that the potential difference between 2 points is 1 volt. Okay. So if 1 joule of work is done in moving 1 coulomb of electric charge from one point to another, that is what the point. If 1 joule of work is done to move 1 coulomb of electric charge from one point to another is called this is what it means. Okay, simple way of asking, but they just want you to understand. Right. The next question is, how much energy is given to each coulomb of charge passing through a 6-volt battery? This is one of the, of course, easiest question. Same definition, V is equal to W Q. Using that formula, we are asked to find out how much energy. Work done is nothing but energy. So work done, we have to find out. Charge is given 1 coulomb. Each coulomb means 1 coulomb. And potential difference is given 6-volt battery, EMF. So charge is 1 coulomb. Potential difference V is equal to 6 volts. So we have to find out energy or otherwise work done. So we know that V is equal to W by Q. Right? So W is equal to V into Q. Substitute as 6 into 1, 6 joules. Here the energy is equal to work done. Okay. So we have to complete the sentence. How much in place of how much? We say 6 joules. So 6 joules of energy is given to each coulomb of charge passing through a 6-volt battery. Okay. This much energy is given. We can complete the sentence. Is that clear? So same formula only we are using. The next one is, on what factors does the resistance of a conductor depend? Actually, this question is based on the resistivity. You know that resistivity and the resistance. Using Ohm's law we have seen. R is equal to rho L by A. Isn't it? That formula. R is equal to rho L by A. Here there are 3 variables only, rho L A. But according to Ohm's law we have seen, provided the temperature is constant, we have seen. At a constant temperature, the potential difference between the two ends of a conductor is directly proportional to the current flowing through that, isn't it? That is what the Ohm's law says. V is proportional to I. So the condition is the temperature should be a factor, constant. So we are adding that point also as one of the factors. So what are the factors? From this formula we can say the length of the conductor L, the length of the conductor, first point. Then area of cross section of the conductor, area of cross section A is inversely proportional to A. And then nature of the material of the conductor. Why do we say nature of the material of the conductor? It is rho. Based on nature only, the rho will be changing, isn't it? So whether it is metal or alloy, depending upon nature, the resistance will be varying. And finally, as per the Ohm's law, we have to say temperature is also a factor. So there are 4 factors. So by mistake, usually we used to write only 3. You have to remember that temperature is also a factor, because as the temperature increases, the resistance will also increase. Okay, as the temperature decreases, the resistance will also decrease. So that using that point, we have added there are 4 factors on which the resistance of a conductor is depending on. Okay, right. The next one, when current flow, will current flow more easily through a thick wire or a thin wire of same material when connected to the same source Y? That is the question. We have discussed this point. If the thick wire is there, that means that thin wire has got a lesser area of cross section. Thick wire has got, thick means they say that the area of cross section is more. Right? If area of cross section is more, what will happen? What will happen? It will allow more charges to flow through that. So that means the resistance will be decreasing. As I told you, you remember this point. I remember in a ground, I said in a ground when more people are there. I remember that if more people are there, it's very difficult to go through them, isn't it? That's what I said. Remember that. So using that formula, same R is equal to rho L by A, the area of cross section, resistance is inversely proportional to the area of cross section, isn't it? Inversely proportional to the area of cross section, or we can say square of its diameter, that is inversely proportional. So A thick wire has got a greater diameter and hence lesser resistance, making the current to flow through it more easily. Yeah. Instead of saying like this, we can say using that formula. We know that rho is equal to R is equal to rho L by A. Right? The resistance of a conductor is inversely proportional to the area of cross section. Okay, this instead of saying it in a sentence, if you write the formula and say the resistance is inversely proportional to the area of cross section. A thicker wire has got a more area of cross section. That means the resistance is lesser, so that it will allow more current to flow through. Easily we can say. Okay. So always if formula is available, using the formula you can explain easily. Okay. This is how we have to arrive to the solution. The next one is, let the resistance of an electric component remain constant while the potential difference across the two ends of the component decreases to half of its former value. What change will occur in the current through it? They say that resistance is same, only the potential difference is increasing. What will happen to the current? So we know that according to Ohm's law, V is proportional to I. If V is increasing, I also will increase. If V is decreasing, I also will decrease. Isn't it? If V is V by 2, then I will also be I by 2. That means current will also decreases to half of its former value. So by this way, if you use the formula, so that it's easy for you to understand and give the answer correctly. Okay? So mention always like this. And then the next important question. Why are coils of electric toasters and electric irons made of an alloy rather than a pure metal? There are two important points. We have already discussed it. Try to recollect it. A resistivity of an alloy is generally higher than that of a constituent metals. What are the component metals are there in alloy? They will have the resistance. But if you combine them, the resistance will always be higher than the individual metals. That is the first point. Okay? Why? Because if more resistance is there, what will happen? They will produce more heat. That is why they are used in electric toaster or irons. So they have to produce, if they are resisting the flow of current, the energy of the electrons will be converted into heat. They have to give out the energy. They cannot be staying with more energy. Isn't it? So if it has got more resistance, then only they can generate more heat according to the Joule's law of heating. When current flows to the conductor, it will generate heat. The energy of the electrons is converted into heat energy. So that is why we choose an alloy instead of metals. Okay. So alloys, the resistivity is more than the individual metals. And the next one is, when more heat is generated, it will be at a high temperature, red hot we say. Red hot iron box and all, if it is left for some time without giving attention, what will happen? The iron box will become reddish. Even then, the resistance, alloy will not, the filament, resistant filament inside will not get burnt. That means they do not oxidize. Oxidize means reaction combining oxygen, burning. Even at high temperature, they do not oxidize readily. So these are the two reasons why we are using this alloys instead of pure metals. Okay, these 2 points you have to remember. Okay. The next one is, which among these two, iron and mercury, is better conductor? Which metal is the best conductor? Among these two, which one is a better conductor? For this, a tabular column will be given. They will give you a tabular column. They will give the detail values of resistivity. Using the resistivity as it is given in the textbook, you can refer the tabular column. By using the tabular column, we can compare whether iron or mercury is a better conductor. When you look at that, for iron the resistivity is 10 into 10 power minus 8 ohm meter. But for mercury it is 94.0 and 10 power 8. So when you compare these two, this is high resistivity. That means this will offer more resistance for flow of current. But iron will be offering less amount of resistance. So that we say that iron is better conductor than mercury. Right. So in the tabular column, among all the metals given, we understand that silver metal is the best conductor because it has got the lowest electrical resistivity, which is 1.6 into 10 power minus 8 only, very low. So these points you have to remember. The resistivity of iron you have to remember, resistivity of silver you have to remember. This is the lowest one. Sometimes they may ask, because it is one of the lowest value in the tabular column, they may ask you which the resistivity, electrical resistivity of silver is. They will ask 1.6 10 power minus 8, 1.6 10 power plus 8, or 1.6 into 10 power minus 18, like this they may give. So remember that it is 1.6 10 power minus 8 ohm meter, which is the lowest. So that since the resistivity is low, it offers a very less resistance, so that it will allow more current. Right. So with this we will stop, and in the next class we will see the resistance of system of resistors. And more resistors are connected in series, how to calculate the resistance. Okay, we will continue in the next class. Yeah, right. Thank you.